Yeah, hello everybody. Thank you for the opportunity to present here today. I'm working for a company called Deepfield. My name is Stefan Meinders. I'm a replacement today for Craig Lebowitz, who created this presentation and presented it at the Global Peering Forum. So let's try to get a look into what is the new internet, or what is new about the internet, because the internet exists for several years, and something has changed that made us up to call it the new internet. So it's a little bit about data sources and analyzing this data. What kind of data sources do we have? Another one as well? Okay, yeah, okay, sorry. So we have two different data sources. One is the cross-ISP report, which is a research collaboration of the Cable Labs Institute, Princeton University, and Deepfield. It contains of data shared by 7 publicly announced participants, so cable operators in the US. And this represents more than 50% of the US internet consumer traffic. The other data source we use for our trending data, I will show in a few slides, is the Internet Observatory initiative. So it's a research collaboration with participants like Deepfield, University of Michigan, Marriott networks we use for demos. If someone has seen a Deepfield demo already, it's the Marriott network we are using for it. It includes the Internet Observatory initiative includes fixed line operators, CDNs, and content as well. It is statistically significant amount of consumer traffic from North America. Around about or less than 10% of that is European traffic as well. So let's get started with the cross-ISP report. So the participants are shown on the left-hand side. It's Bright House, Comcast, Cox, all these large eyeball carriers in the US. And what exactly has been monitored here, has been used in this report? So the data collection was on their peering interfaces, peering transit interfaces, and interfaces to other content networks. So the idea was to figure out if there is network congestion, where is this congestion? Is it the peering capacity between these eyeball providers and their transits, or is it somewhere else in the network? And is there, congestion at all? So that was basically the idea. Coming back to the second data source, the Internet Observatory is, like I said, research collaboration of several institutes and Deepfield. It's aggregated data from routers, and in this case, it's data from DNS servers as well, which provide us more information about which site exactly is used, not only BGP passes, SNMP, and NetFlow data. So it has DNS information available as well. It's using middle boxes, something like inline devices, to do some kind of deep inspection as well. So, and of course, it's measuring security events like DDoS attacks on the networks. And it has, additionally to it, data on CDN services. It knows how much data has been transferred, what kind of payload was it, what kind of OTT service have we seen or is there in this network. And information about the quality, how these streams, for example, are delivered to the users, and something about what we call cyber supply chain. So often it needs several networks to get one service working, like Netflix, for example. Netflix currently is delivering these small thumbnail pictures for their catalog via the Akamai network, but their videos are delivered from their CDN directly. So it needs two different kind of networks, two kind of peerings to have these services working. So In addition to that, we do daily crawling, so we crawl the entire IP space. If we identify IP space which is not so interested to crawl it more often, like subscriber prefixes, for example. If we have identified once that this is a subscriber prefix, we don't crawl it every day, of course. So this makes it possible to crawl the entire IPv4 space, and for IPv6 we concentrate on the assigned IPv6 space. So this Internet Observatory initiative allows us to get an idea of where is which kind of traffic delivered, how is it delivered, what's the quality of this traffic. Going back to the cross-ISP capacity report, so this report is looking into capacity as well, and the expectation was that there is some kind of congestion on these links between these ISPs because sometimes services just fail. Today, it's, a service is working when the quality to deliver this service is good enough. So as soon as, let's say, a movie is delivered no longer in HD quality, it's dropping down to SD quality or even stopping because there's not enough available bandwidth, the service is down. It's not only slow, when it starts buffering and these kind of things, then the service is unusable, so it's down. That means slow is the new definition of down. These networks need some kind of spare capacity to allow more utilization during peak hours. There's a whole lot of traffic during peak hours when people are using Netflix or other video streaming services. So the expectation was there is some kind of congestion in these networks. But what has been figured out in this network, it was monitoring these large cable operators over roughly a year. The report then concentrated on 6 months of data, what we see here from October to March. We figured out that the utilization of these interconnection links is only about 50%. So if we look at median or at 95th percentile, it's roughly about 50%, so there's a lot of spare capacity. That means, on the other hand, if a service is not running really well for one of these eyeball providers, the problem is not really in their hands. Their peering has enough capacity to get the traffic delivered, so the problem must be somewhere else, maybe in the transit networks or so. So this report, if you are interested in downloading it, it has been created by Nick Feimster, who's a well-known scientist on networking measurements and statistics and so on. So you probably will find this report. Another part of this report is the month-over-month growth of network traffic or utilization and capacity growth. So the lighter green shows the peak usage and darker green per month here shows the capacity. So of course the capacity has been increased month over month as well by these network operators. There's quite a huge spike in January. So my idea why there is a spike in January is that many people have been have gotten new larger screens, televisions for Christmas, and started using them during January. And of course, many people were at home, were on holiday during this Christmas period, and watched a lot of video, of course. So we know from our data that most of this is indeed video streaming traffic. So at the end, what we can tell from this report is that we, at least in the US, see a quite healthy network. This is somehow concentrating on US traffic currently, but we, as Deepfield, run trials in the European region and in the more eastern region as well. And what we see there is somehow different. So in our region, it's not common that we have 50% spare capacity on our transit links and peering links. So we see more often utilization. Coming to internet trends, and this is a report which is built out of this Internet Observatory. So where is this traffic coming from? How can we look into the distribution of traffic? So this is a cumulative distribution graph. It's very often used by computer scientists. They like these kind of graphs. What we see here is, if we go down this red line and where it crosses the blue line, that is where we see roughly 50% of internet traffic. On the X scale down there at 151 is the number of ASNs where this traffic is delivered from. So 2009, which is the blue line, 50% of internet traffic was delivered by 150 roughly different ASN numbers. I skipped 2007 now because it was just different. In 2013, there was 50% internet traffic delivered by only 35 different ASNs. So the trend is that less number of different sites or ASNs deliver 50% of internet traffic. Most of the traffic is coming from a small amount of organizations, ASNs, or even sites. If we extend this now to 2016, so what we have seen so far is that on average, only 10 different ASNs generate 70% of consumer traffic. This is currently based on US data, on US traffic. So 30 ASNs, if you peer with these 30 ASNs directly, you would be able to have 80% of all traffic covered, right? So the end, if you would extend this green line to very high numbers, you would identify that there are many, many different sites on the internet as well, of course, but you need transit to reach these other ASNs. Another thing we looked into was IP counts. IP counts is an interesting graph. It's looking into IP addresses, consumer IP addresses, and it's checking how many of those IP addresses are connecting to google.com, for example, for a period of 24 days. So during a day, roughly 60% of all IP addresses have had a connection, at least once, short, to google.com. And yeah, we can go down the list now as well. So we see cloud.apple.com and so on. So apple.com is always in this list as well, because everyone who has something like an Apple TV at home, this will connect at least every day to say, okay, I'm here, I'm subscribed to these services. Same for audio traffic services like Spotify, for example. So we are heading into a world where we have these very large ASNs, very large networks that try to move into even smaller locations. So currently this traffic, the entire traffic we've seen is delivered via CDNs. It's no longer your transit, it's not longer your IXP peerings where you get the majority of traffic from. You get the majority of traffic from your CDN peerings. These CDNs are delivering the majority of traffic. And they start to build out more and more, and they even go to the second cities. We could call it the second largest city per country. So it's not only that they connect or build servers in data centers in Moscow. They go to St. Petersburg and other smaller cities as well. So they go to these second cities because they have challenges to deliver the traffic in good quality to their customers. And they want to be as close as possible to these customers. So that's basically, the world is a little bit changing from you don't get the traffic via your peerings, IXP peerings and transits anymore. It's the CDNs delivering most of the traffic today. So if we look into CDN traffic as a percentage of the ingress traffic into carriers these days, it's that in 2015, 60% traffic is coming from CDNs today already as a distribution compared to the ingress traffic overall. So we can look at CDN traffic compared to the backbone traffic. This is more or less stable, or has been stable. Over the past year, it's growing at 1% per year, so that's not so dramatic anymore. That's because, the market maturation and so on, it's already quite stable, that if the backbone traffic grows, the CDN traffic grows as well. In case of CDNs, we have, or data from these CDNs, we have different types of data. So currently, most of the traffic is average bitrate traffic, which means that, adaptive bitrate, sorry, that the client is more or less in control of the bandwidth being used. As soon as your video client notifies, okay, I can get 5 megabits per second, it will automatically switch to HD and use this 5 megabits per second, of course. If only 2 megabits per second are available, it will go down to SD streams, for example. So the client is in control of how much bandwidth is used. What not necessarily means that a link that is fully utilized is delivering a bad quality of service to the customers using this link, because the average bitrate used per client might still be okay. So you have different KPIs these days. You need to monitor to identify, okay, this service is running well, or this service has problems and I need to do something in that region, in that POP. What we see here is that we have different services. The blue one is Open Connect, which is Netflix traffic, which has huge spikes during primetime hours, of course, and something like the yellow one, which is Akamai traffic. They deliver different kind of sites, so this is more stable. It's not these large peaks during primetime hours. We have other observations. So what we can see here in the graph, the cubism graph in the background, which is the orange and red one, you see when Open Connect, that's Netflix traffic, is filling their caches, right? That's roughly at 3 o'clock in the morning. So what network operators might need to do, they might need to coordinate when is the best time for a certain CDN to fill their caches, when is enough network capacity available to fill these caches. And this is an easy view to show all the CDNs underneath. And make sure they choose the correct time to fill it. We are monitoring new players here as well, like Fastly or Cloudflare, CloudFront, starting in the CDN market as well. Some of them have been known as anti-DDoS providers already. Another comparison we did is we compared Netflix traffic being encrypted and Netflix unencrypted traffic. That's an interesting graph as well, because what we can see from this graph is that Netflix currently encrypts SD streams, which is possible because it's lower bit rates, but HD streams are currently not encrypted, maybe because of CPU power. So this is something we noticed as well. A very quick summary about these reports. So compared 2015 with 2005, we see that most of our traffic is today delivered via CDNs, and we need new tools to look into it, to identify what's going on, because traffic from Akamai doesn't tell you anything about which kind of services it is. Is it video streaming delivered via Akamai? Is it just web traffic, or which kind of traffic is it? So if you're interested in this, you need more data. Deepfield has built a new platform to get this data and correlate as many data sources as possible to make these reports available. There is a session later today, a talk session where it's about measurements, and I could explain something about that as well if there are more questions. Basically, the idea is we have different data sources, different logic engines, and compare and correlate traffic and build reports based on it, do alerting, and all these kind of things. This is a graph. I'm a little bit running out of time. Showing in the middle our Singularity engine have southbound connectors where we get data from the network, and northbound connectors where we can provide data to other systems in your network to do closed loop orchestration, for example, to do network automation and things like that. This, at the end, allows us a wide-angle correlation, so we can show you what's going on in your network, where's traffic coming from, where is it going to, on which POP, which kind of traffic is it streaming traffic, has it some real-time requirements, and so on, and this can be done in the entire network with our analysis platform. So thank you, and any questions, if there's time for questions.
Yeah. Okay, we do have a couple of minutes because we started 5 minutes late, but we managed to be 2 minutes early. Какие-нибудь вопросы у нас есть? Пару минут и один-два вопроса, я думаю. Окей, пожалуйста.
Factor Group, Evgeny Zobnitsov. I'm starting from Russian. I wanted to ask you the question about you talk about the new trends that the more traffic we have gotten from the internet, from the less autonomous system.
Yes.
What does it mean that to have the network connectivity, you just need to connect to the CDN caches and do not care about connectivity at all, or any other points of view?
Yeah, of course. That's not the idea behind this talk, right? Forget about the other 20%. So we could break down the other 20% as well. I can tell you most of it is hosting. There are a lot of services in hosting. Another huge amount is gaming traffic. And of course you need these kind of traffic, but it's delivered differently, right? So gaming traffic is mainly delivered via the IXPs because they want to be as close as possible to the subscribers as well. So IXPs play a very big role in that as well. The conclusion about this huge amount of traffic and why it's important to know is that there is so much, let's say, video streaming traffic already, and you get into challenges monitoring this traffic. As soon as you know this is video traffic, it's already good enough. You don't need to do deep inspection, for example, on video traffic, because you are mainly, as a network operator, interested in that the movie is delivered in good quality, but you're not interested in the fact which kind of movie, or which movie is the customer currently looking. That's not really interesting for network operators. The problem is, if you have so much video traffic, it's hard to fail it over. So if you know, okay, I have 1 terabyte of Netflix traffic, do I really want to have 1 terabyte spare capacity if my primary link to Netflix goes down? And what might happen if my peering to these certain CDNs goes down? Where does the traffic appear then? That's the main.
Thank you.
Thank you, Stefan. And let me just add, there are people who use messengers, right? There are lots of important traffic over IP, which
Yes.
would never be served by CDN ever. So I wouldn't worry about it. The long tail is really long. So I think we're just about to be on time. So thank you everybody for being here. Большое спасибо за ваше участие и увидимся.